The title of the talk today is Towards Accelerating Existential Risk Reduction Against Near-Term ASI. It's what not many people do, but I believe because of that it's fairly important. And the approach that I'm proposing and taking is to try to automate identification and prioritization of effective safety interventions. So more to that now. And you may see some visual kind of cartoony cues in the bottom right of each slide or some of the slides, and you can in the end give a guess of what I'm trying to hint at. So please follow those. Part one, why near-term ASI X risk? It's something fairly out there, sounds like a lot of assumptions, sounds like maybe too complicated to do, but let me make a case here. So one starter is to get you guys to think in a certain mindset, which is not when you pull up Claude today. So this is a different class of AIs. What I'm talking about is wildly superhuman, and there's probably variants of this depending on what we get to and how soon we get to it. But these models may acquire their superintelligence at the end of pre-training. So not only when it's deployed, but already a good amount earlier. It may have superior situational awareness. It may have self-preservation, so resistance against changing its own goals and setup, which means it may be robust against fine-tuning and reinforcement learning. It may persist its own goals throughout that situation, and that comes with alignment faking, deceptive sandbagging, what we already have now. And it may be superior against cybersecurity and control, meaning that any amount of attempt that we have to confine it, to control it, it may easily step over and do what it wants to do, including exfiltration and pursuing its own convergent goals. So that may, if we're lucky, include learn about the universe. And once it's ready or has learned everything about Earth and humans, it may want to go out in the galaxy and leave the planet. But that's kind of up for debate what it would do then. My claim is that barring any bottlenecks in compute and data, this AI class may likely be created. So at some point, if you just keep scaling, like the graph indicates here, this may just pop out. And that includes accidental creation of such AI systems, which is scary because it may at some point knock on our door kind of, and we may not have seen it coming, and that's what that oops thing is about on the top right. The last one there is just the estimate of current PDoom. It's about 1 to 10% existential risk from ASI, and there's varying definitions of what existential risk is. The slide deck is on the Discord, where hopefully all the references are clickable. So if you're interested in what I link here, this is how to get to it. So this is just kind of a primer to get you guys thinking in this mindset. This is not your usual Claude, ChatGPT, whatever, Grok, other things. This is something different. Now I see three challenges to this. Challenge one is timeline. In the beginning, I said near term. So I claim that in a substantial subset of worlds, we have very limited runway. AGI, and I call it here with an asterisk because what I need or claim or need for my claim is only that this AI can automate R&D. Not that it's generally intelligent by whatever other definition. It just needs to be able to accelerate R&D progress. And there is a good amount of fraction of people who think that this may happen soon, within the next 1 to 3 years, and enable then this automated capability R&D. And on the top right, I show a screenshot of AI 2027 folks, where how they forecast the superhuman coder, which is what I mean by AGI asterisk. And they have their peaks fairly near term. There's obviously a long tail, but still, that seems to be coming around fairly soon. And then combining with the first Metaculus prediction there, the lower 25% of forecasters think that AGI in that context will emerge also within 1 to 3 years. Then the second step is what happens after an AGI is available that can automate research. Probably capabilities will scale a whole lot, this intelligence explosion or accelerated development, such that Metaculus forecasters again think that ASI comes out in the median 27 months, that's in units of months, after this automated AGI asterisk becomes available. And that's not a lot, so that's another kind of 2 years on top. There is the bottom line now here about this slide is we may need to we may get ASI in 3 to 6 years, and we may need to have effective solutions in place in that time frame, which from a product development standpoint, where I worked before, is fairly soon if you need to kick up a whole new program. So anyway, there's 3 to 6 years. Second challenge is current safety approaches may be insufficient. So currently in alignment, our methods right now require, in the case of Anthropic at least, external classifiers. The model itself is not safe enough to deploy it by itself. So we need those guardrails, input classifier, output classifier, and there is plenty evidence for emerging issues. And that includes the whole slew that we have already heard in this conference, convergent goal pressure, sandbagging, alignment faking. They scale and seem to intensify with model capabilities and a bunch of references, including AI control. So also there, this recent paper this year from UK ASI, Paula Redwood, indicate that ACL5, the top right thing there, is where control seems to break down, and we need breakthroughs, they say. So we may need breakthroughs, not incremental improvements. That's the bottom line 2. And finally, challenge 3, safety tends to be second priority in frontier labs. And that is, there's no scientific papers about that. There's news reports, so that's kind of less strong. But I think everybody agrees that this is a current problem. And during acceleration, this gap may widen because everybody will be excited to crank out very capable systems very quickly. And safety will kind of creep along, but will always be behind. And this is a graph from Joe Colsmith, that the issue is when the safety line here of red is broken through by capabilities because they accelerate much faster. And then we have an issue. And here it says loss of control. So bottom line 3, we need to try to get safety progress to the same starting point at least as capability progress. So those are kind of my 3 challenges to not have issues once very capable AI systems may become available in the near future. Here again summarized, those bottom lines. And I believe one solution candidate, and I believe for myself anyway, it may be the only one that is somewhat, or shows the most promise, is to accelerate safety R&D. There's some known entities that work in this area to some extent, known to the public, Safe Superintelligence from Elias Sutskever. Not sure what's going on there, they're kind of in stealth mode. Law Zero from Yoshua Bengio is advocating for a different architecture, but not necessarily replacing current paradigm models, so it's not really a full solution there. And then Cordinal Research is a small startup that tries to automate the back end of safety R&D, not the full safety R&D itself. Now, part 2, how to accelerate safety R&D. The main part that I'm focusing on is the first step in the R&D workflow. And the R&D workflow is just the 4 steps here. So find promising hypotheses, and then design an experiment, execute an experiment, evaluate the experiment, and go back up. So that's kind of a loop. And the first part, the find promising hypotheses, that seems to be in reach because currently there's concerns that we're not there yet to do a full automation of the full loop. The current agents, they kind of get lost on the way when they execute the experiments. The time horizon of execution is not so long yet. May not produce reasonable work, but the first step may actually be in reach and feasible by doing something that I described here in the last slide, which is 2 steps. 1, we can harvest existing interventions from appropriate sources. That's the archive preprint server, whatever, 50,000 papers on AI safety, or so let's say 10,000. Less wrong than others. And this will be executed in a project that I'm hosting in Eleuther AI. It's kind of written here vertically, starting in 1 or 2 weeks. So that group will implement one of these design options here with some validation options. If anybody has ideas for more validation, let me know. This is a little bit of a challenge here. And the second one, after one has harvested all these interventions, is to build a framework to assess each intervention, like what's its potential for ASI X risk reduction. And some approaches that exist are involving utility functions, tiered preference hierarchies. That will be discussed in today's workshop. So the red box is the plan for later today. And there's an opportunity maybe to get this work executed in a SPAR project that's coming up in September. So that was the quick overview. Theory of change for anybody to read up on. Some concerns about differentially accelerating defensive capabilities, DEFAC, for folks to read up on too. So not accuse. Anybody any suggestions what I'm hinting at here? There's a rabbit, an evil rabbit. That's dynamite. Matt? The Holy Grail, Monty Python and the Holy Grail. Yes, sir. All right. So extra credit for Matt. Thanks very much.